Welcome to a new episode of Computer Vision Streams. I'm your host Anton, and today we continue to learn about NVIDIA Jetson Metropolis microservices, and we will see an example of zero-shot detection AI service based on a NanoOWL model. So these servers will consume RTSP stream that we will generate from NB Streamer or from Video Storage Toolkit, and it will try to detect different classes that we will define by using a text prompt, and it will output another RTSP stream with generated detections and metadata to the Redis database. Before going into installation details, let's take a look at what stands behind NanoOWL model. So NanoOWL model is a small version optimized for NVIDIA Jetson platform of open vocabulary detection based on visual transformers. Open vocabulary is different from classical object detection models is that we can define the set of classes that we would like to detect during runtime with plain words. And because our model learned how to align language and images, during training, it is able to detect even the objects that we didn't have specifically in the training dataset, but the model learned about them from the text to image pairs in a huge dataset. So here we see an example of a person, and we can introduce different classes as a text, and the model starts to detect them. We will play around it after we will install this example. So the first thing is to install Foundation service that will provide support for Redis, SDR, and also monitoring services. For that we need a recent version of Jetpack, and we can install NVIDIA Jetson services. Afterwards, we can download archive and extract it. Next step is to copy configuration file for our Ingress foundational service. And we can restart Jetson Ingress and Jetson Redis services. After that, we can use Docker Compose file provided in the installed archive to run our AI service. It will take around 3 to 5 minutes to pull the images, and also a couple of minutes to build optimized TensorRT engine from ONNX model. We can consult logs of GPS zero-shot detection container to verify that service is running, and we have access to Swagger API on the port 510. In this API, we can get the current live stream, add live stream, delete it, and also add what kind of classes should be detected on this live stream. I already prepared a live stream that is generated by NB Streamer, and you can see how to generate streams from your video files with NB Stream in one of the previous videos. So first we will add a stream to our service. And we will retrieve the ID of process stream. We can retrieve it as a variable to reuse it in the future commands. We can check that our service is outputting the stream, and we already have detections from previously defined classes. Here we have the classes of a person, a car, and a bus. These predefined thresholds, and you can see that it was able to detect those objects. We can try to play around and test the limits of NanoOWL model, for example, to see if it will be able to detect trees, buildings, or even something that is not well defined on an image, like a shadow. When we update detection classes, it should consider those modifications immediately, and we can see different detections of trees and also a shadow. Open vocabulary models are very powerful, but at the same time, with this power comes a lot of limitations. And usually it might be interesting to consider those models for data collection, to get the detection, and then train a classical object detection model with fixed classes to achieve higher accuracies and higher performance on important classes. We can also check that the metadata is generated and is sent to Redis storage, so that we can use this command, check for next metadata message, and effectively we will see all the objects that are generated, their bounding boxes and classes. When we finished working with a stream, we can delete it and remove container with Docker Compose down. In the example 1, we don't have a persistence of configuration of a stream, which we can see in the next episode by using another service that is called Sensor Distribution and Routing Service to have persistent configuration of detection classes and the associated streams. If you want to learn more about NanoOWL model, don't hesitate to go to the repository or read the original article about OWL bit transformers. If you want my review of this model, please write the comment below, and I will see you in the next episode.